Okay, so I think today's topic, you're going to find it pretty easy. It's reflections on the coordinate plane. So let's just talk about what a reflection is to start with. A reflection flips a figure over a line of reflection. So we're always going to have some line. In our case here, it's going to be the x-axis or the y-axis. When you get into geometry and learn some trigonometry and stuff, you can make any line you want your line of reflection. But for us, we're going to use the x-axis and the y-axis as our mirrors. There's another term that's used besides line of reflection, and I want you to be familiar with it. So we can say line of reflection. We can also say line, write this down, please, of symmetry. Symmetry. So you might hear line of reflection or line of symmetry. I want you to be familiar with both. They mean the same thing. It's the line that you're using as your mirror. Okay? So a line of reflection in order to create a mirror image. So write the word mirror there. Each reflection point or figure should be the same distance from the line of reflection. On the opposite side. And that's an important concept. That's basically the concept that we want to consider. In the easiest way to reflect something is each reflection point or figure should be the same distance from the line of reflection. That's that depth you notice when you look in the mirror, right? Things behind you look behind you in the mirror. Things, well, your facial features, they look like they're in depth a little bit. And that has to do with the concept of equidistant. So we're going to go ahead and reflect this triangle, WXY. And they always tell you over which line of reflection, over the y-axis. So I'm going to highlight the y-axis. This is my mirror. Okay, I'm going to reflect over that line. So the quickest and easiest way to reflect anything is you pick a point. I'll pick W. How far is it from our line of reflection? 2 spaces. So you go 2 spaces deep on the other side of the mirror, or in this case, the y-axis. I'm going to go here. 2 spaces in on the other side. And this is going to be W prime. Okay? Let's do the same thing with X. This is 7 spaces away from the y-axis. So this needs to go 7 spaces in. 1, 2, 3, 4, 5, 6, 7 right there. Okay? So this is where I'm going to put X prime. And the same thing with Y prime. It's 2 spaces away from the y-axis. So from the y-axis, go 2 spaces in. And we just reflected this. So this is part of what you're going to do today on the IXL, by the way. Let's just connect this to make our triangle. And there you go. It's a mirror image. Okay, so let's go ahead and we're going to record the vertices. So start with W, X, and Y. We're going to record the X and Y coordinates for those. So we had 2, 6. X was 7, 4. And Y looks like it was 2, 2. Okay, so we'll record W, X, and Y. Then we're going to do the same thing with the image points, W prime, X prime, and Y prime. And then we're going to see what the differences are. Okay, so for W prime, it's -2, 6. And then X prime was -7, 4. And for Y prime, it was -2, 2. Okay. Go ahead and write those down. So for part B, it says, describe how the reflection affected the X and Y values of each vertex. So let's look at the X values first. We went from 2 to -2, 7 to -7, and then 2 to -2 again. What was the change there? Yeah. Basically, switch sign, right? Because it's going to turn out that if these original values would have been negative, they would have flipped to positive. If we would have been down here or over here and flipped the other way, we would have gone from negative to positive. So the X values switch sign. Okay. How about, let's compare the Y values. What do you notice on the Y values? Stay the same. And that's what's going to happen when you reflect over the Y-axis. You flip the X values and you keep the Y values the same. So the way we would represent this algebraically in this transformation notation is like this. X, Y maps onto, that's what this arrow means, -x, comma, y. -x, comma, y. Okay. So if you don't have a graph, but you have some points that you need to reflect over the y-axis, this is what you would do. Switch the sign of the x values and keep the sign of the y values. Okay. All right. Any questions? Let's reflect over the x-axis. So this time we're going to take DEF, triangle DEF down here in quadrant 4, and we're going to reflect over the y-axis, over the x-axis, I'm sorry, over the x-axis. So let's try that. This time our line of symmetry is the x-axis, this right here. This is our mirror. Okay. So we're going to flip over here. So it's the same process we did, except using the x-axis as our mirror. So let's start with D. D is 2 spaces away from the x-axis. So you go to the x-axis and you go up 2 spaces. It's going to go here. And so this is going to be D prime. E is 7 spaces away, right? Because we're going from -7 up to 0. So here we're going to go up to 7. So it's 7 spaces equidistant away. So this is E prime. And F prime is also 7, but at 2. So we're going to go here to the x-axis and go up to 7 this way. And so here's F prime. And let's make our triangle. All right. So same thing as we did for number 1. Let's record the coordinates for D, E, and F to start with. Okay, so this time we're in quadrant 4, so it's going to be positive for X and negative for Y. So this is 2, negative 2. Oops, ignore that prime there. Oh, getting ahead of myself. This is going to be 7, negative 7. And then 2, negative 7. So that's G, E, and F. Now let's do the image points. Okay, so this is going to be 2, 2. And E prime is 7, 7. And F prime is going to be 2, 7. Okay, there we go. Okay. What do you notice? Let's compare X values. We got 2, 2, 7, 7, and 2, 2 again. Would you say they'll stay the same? They'll stay the same. How about our Y values? We went from negative 2 to 2, negative 7. Those switched. Those switch sign. You could, from what we did before and what we just saw here, you could probably guess what the algebraic representation for this is. XY maps onto X negative Y, yeah. So XY maps onto. So this is the original, and the new value is going to be X negative Y. Very good. So when you're reflecting over the x-axis, the y values change. Okay, that's usually how I remember those. Any questions? Okay, let's look at what's on the back. Excuse me. So we're going to use this reflection. So this is our pre-image. So our pre-image is here. And this is our image. Use the reflection shown to compare each statement below. All right. So A, give a verbal description of the translation. What type of translation was this? Over the x-axis or over the y-axis? Yeah, it's over the y-axis. This is our mirror. So let's write that down as our verbal description. Reflection over the y-axis. Okay. Reflection over y-axis. That means the x values are going to change. So let's write the algebraic description. So this is going to be x, y maps onto, what would this be? Is it negative xy or x negative y? Negative xy. When it's over the y-axis, x values have to change. Okay. Part C. List if each of the following changed or stayed the same. Let's start with the size of the figures. They stay the same, yeah. So we'll just say those are the same. Orientation of the figures. Compare the pre-image to the image. Are they facing the same way? No, it's a flip. Literally, it flipped. So that's going to change the orientation of the figure. So that was definitely a change. How about the orientation of the vertices? Looks like if I go PQ to R, P to Q to R, that's going clockwise. If I do the same thing with P prime, Q prime, and R prime, is that going clockwise? No, it's going counterclockwise. So that changed as well. That's one key way to tell. Sometimes it's going to be hard to tell. Was this a reflection or was this a reflection or was this like a translation, a slide? And one key way to check the orientation of the vertices. Okay. And interestingly enough, that's our next question. Take a look at question number 4. Bella believes the graph shows a translation down, while Scott believes it shows a reflection over the x-axis. Who is correct? And then explain. So Bella believes it was just a straight slide down. And Scott says it was a flip over the x-axis. Which one was it? How can we tell?
Because the orientation of the vertices.
Yep. Basically, here we're going clockwise. And to do the same thing here, you've got to go counterclockwise. So Scott is correct. It is a reflection over the x-axis because the orientation of the vertices changed. Okay. Move that up so we can take a look at number 5. We're almost done. Triangle ABC has the coordinates shown in the table. Okay. Miguel is going to reflect the triangle using the rule x, y maps onto negative x, y. What is the line of reflection? Are we reflecting over the x-axis or over the y-axis? Which one is changing, the x value or the y value? Looking at the rule. X, right? Here it is. Negative x. So when x changes, what's our line of reflection? X or y? Y. What is the line of reflection? Y-axis. Okay. Okay, so now they want us to just use the rule and write the image coordinates. So we want A prime, and x's are going to change. So this is going to be 4, -6. Okay, and do the same thing for B prime, C prime. 5, -8. And this is one of the other things you're going to do on the assignment today. 1, -3. I had one person in period 1 finish both IXLs in 4 minutes. I think they found it easy. List the coordinates of the image. Okay, we did that. Okay, last thing. 6 through 8. Use the description to identify the line of reflection and write an algebraic representation for each reflection. Okay, so here's the description. Point A was 8, -1, and A prime is -8, -1. So what changed, x's or y's? Did the x values change or did the y values change? X. So when x values change, what's our line of reflection? Y-axis. Okay. So since that's it, the algebraic representation would be -x, y. Okay. So try that on number 7. Let's take a look. The figure reflected from quadrant 1 to quadrant 4. So we got to know our quadrants. Let's look at the graph above. Where is quadrant 1 on this graph?
Oh,
This one?
right.
Oh, okay. So this is, and then it's going to flip from here to quadrant 4. Where's 4? It's going from here to here. So what's our axis of symmetry, or x-axis? Okay. So what's the rule for flipping over the x-axis? And the y switches. Okay. So try number 6 on your own. This is another one. Just look at z and z prime. Compare which value switched. And then write down the axis, x or y, and then the rule. Okay, give it a try. I'll give you a moment. Okay, so this is what I got. I noticed that we went from z to negative, from 7 to -7, going from z to z prime on the y-axis. So the y-axis values changed. So that means it's a reflection over the x-axis. And so that's x -y. Okay. All right. So the assignment is going to be 2 IXLs. And these are going to probably be pretty easy. So if you find them easy and you can go all the way to 100, definitely do that. Yeah. So both of you go. Let's do 2 for 1 deal. And